Okay, topic E, adding algebraic fractions with like denominators. So let's do 1, 2, and 3 just as a warm-up so you can see how it relates to algebraic fractions, because this is stuff that you've been learning since elementary school. So I want you to see the connection between the two, okay? So in number 1, you have 1/3 plus 1/3, which you're allowed to add together because they have common denominators. So that ends up being 2/3, right? If you've got a third plus a third, you end up getting 2/3, all right? And number 2, see if you can figure out what the answer to that is. You should end up getting 5/5, right? Which reduces to 1, all right? And then in number 3, you should end up getting 4/8, which you know reduces to 1/2, okay? So in order to add or subtract fractions, they must have a least, hopefully you know the next two words, common denominator, and we'll call it LCD, okay? And then after you add the fractions, just like we did for these questions right here at the end, you have to simplify if possible. Okay, so in question number 4, you have x over 8y plus 3x over 8y, right? Hopefully you guys are following what's going on right now. Enjoy it, because this is where things are still easy. We haven't gotten to the hard part yet, okay? So make sure you guys are still with me. They have like denominators, so all I have to do is just add my numerators together. Nice and easy. I end up getting 4x over 8y. But the 4 and the 8 are both divisible by 4, so this becomes a 1, this becomes a 2. So my final answer is x over 2y. And then I'm done with that question, okay? Now, in number 5, you need to be super careful. This subtraction sign will mess you up if you do not pay attention, okay? So first of all, the good news is that they have the same denominator. So I know it's going to be x minus 2. Now, pay close attention to this right here. The numerator is going to be 3x minus, this must be written in parentheses, this 2x plus 2, because you're not just subtracting this 2x right here, you are subtracting everything. Okay, so everything is getting subtracted on that side right there. Distribute the negative, hopefully you remember distributing that negative. You end up getting 3x minus 2x. This positive 2 becomes a negative 2 all over x minus 2. So you end up getting equals x minus 2 over x minus 2. They're both the same exact terms, or the same exact factors, so you end up getting 1, because when you divide anything by itself, you always get 1. Topic F, last topic of the day, adding algebraic fractions with unlike binomial denominators. This is where things are going to get a little trickier. So, same thing, we're going to compare it to what you already know about fractions and adding and subtracting fractions with unlike denominators. Just like we talked before, you have to find the least common denominator. So for example, in number 1, your two denominators are 2 and 4. So basically you're going to find the least common multiple between 2 and 4, which would be 4. So your LCD in number 1 would be 4. So how do I change my first fraction into to have a denominator of 4? Well, all I have to do is multiply the denominator by 2. But I don't want to change the fraction itself. So whatever I do to the denominator, I have to do to the numerator. Because when I multiply by 2 over 2, it's really just multiplying by 1, and anything times 1 is itself. So I'm not changing the number. So this fraction right here will turn into 2/4, which is the same thing as 1/2, right? So I have 2/4 plus 1/4, which is 3/4. Okay, if possible, you're going to simplify at the end. This is not simplifiable, so this right here is done. Okay, now let's look at number 2. In number 2, you have 1/3 and 1/5. So what's the least common denominator between 3 and 5? The only number that they are both going to have as a multiple that's in common between 3 and 5 is 15. So what I need to do is I need to multiply the first one by 5 over 5. Okay, and the second one I'm going to have to multiply it by 3 over 3. So I end up getting 5/15 plus 3/15, right? So that means that my final answer will end up being 8/15. Okay? All right, last but not least, number 3, you have denominators of 2 and 6. They both have unlike denominators, so I have to find my least common denominator. So the smallest multiple in common with 2 and 6 is 6. So the good news is I don't have to change the second fraction at all. So let's go ahead and change the first fraction, all right? So I'm going to change it by multiplying numerator and denominator by 3. That's a 3 in case you can't really read it, all right? So I end up getting 3/6 minus 1/6, which is 2/6, but you can reduce it so it actually ends up being 1/3. Okay, so that's what you do with basic fractions. Same exact thing with algebraic fractions, okay? So first thing you're going to do to find an LCD is you're going to make factor trees or list out multiples of each number. Basically, this right here is what you're going to do for your coefficients. Now, when we talked about finding GCFs, we talked about how you need to look for the lowest exponent for GCFs. Now we're finding LCMs, least common multiples, which means that we're going to actually look for the highest exponent. Least common multiples are basically just the really nice people that want to include everyone. So they look for the highest exponent so that everybody is included, okay? So again, you're going to fill in that you're going to look for the highest exponent. So let's look at number 6 together. In number 6, it says that your denominators are 8x, 3x squared, and 12. So our coefficients are 8, 3, and 12. So what's the smallest multiple in common with 8, 3, and 12? Well, some multiples of 8 would be like 8, 16, 24, right? 32, 40, so on and so forth. Multiples of 3, 3, 6, 9, 12, so on and so forth. Multiples of 12 would be like 12, 24, 36. So what's the smallest multiple in common with all 3 of them? Hopefully you figured out that the smallest multiple in common is 24, okay? So that's part of my LCD, not the total LCD, okay? And then we're going to look and see what is the highest exponent. I've got x to the first, x to the second, and no x's at all. So my highest exponent would be x to the second power. So now I have to go through and change all of my fractions so that they all have a denominator of 24x squared. So basically, I just have to figure out what is missing from each fraction, all right? So I'm going to rewrite this a little bit so you can see it a little bit better. I'm going to leave some space in between so that I can actually do my changing. So in my first fraction, in order to get to 24, I definitely first have to multiply by 3, right? But to get to a 24x squared, I also have to multiply by x. All right, and then this will end up giving me the 24x squared that I want. And then in the second fraction, I have to multiply by 8 to get the 24. It's already at x squared, so this multiplies together to give me the 24x squared, all right? And then in the last fraction, I have to multiply by 2 to get to 24. But then to get to x squared, I also have to multiply by x squared, all right? So then I end up getting, I'm going to put this all together in one fraction. So I end up getting the denominator of 24x squared, right? So 3 times 3x is 9x, plus 1 times 8 is 8, plus 5 times 2x squared is 10x squared. Put it in descending order from the highest exponent to the lowest exponent over 24x squared. See if there's anything in common, anything that can be factored out in the numerator. There isn't, so this is my final answer. Okay, we are going to do number 7 in a minute, but make sure you really get number 6 because number 7 is a pretty complicated question, and I want to make sure that everybody is completely with me on that one. All right, number 7 is tricky, so stay with me. First thing we're going to do is look at our coefficients in order to find our LCD. The coefficient of our first denominator is 1. The coefficient of our second denominator is 1. So it starts off kind of nice for us because the coefficients will be 1, which means our LCD will have 1 for our coefficients, okay? Now remember, we look for the highest exponent for each variable separately, okay? So in the first denominator, I've got a to the second power. In the second denominator, I have a to the first power. The highest exponent between those two would be a to the second power. Okay, and then here I've got b to the third power, b to the second power, the highest exponent, b to the third power. So here is some good news. Our first denominator does not have to change at all. Okay, I'm going to write over here on the left side a little bit because I'm going to run out of room. So you might want to write a little bit smaller. Okay, so my first fraction is 2a squared b squared plus ab cubed, or sorry, excuse me, ab squared all over a squared b cubed. All right, I don't have to change that one at all. Plus ab minus 2b all over ab squared. Now the question is, how do I change this ab squared into a squared b cubed? To go from a to a squared, I'm missing an a. So I got to multiply by a. Okay, and then to go from b squared to b cubed, I'm missing a b, so I got to multiply by b. Now, here is where people will mess up. They will just multiply this ab by this 2b here and completely forget this ab over here. Or if they have this ab on the left side, they won't distribute it to everybody. So this needs to be put into parentheses, and you need to understand that you got to distribute it through. Okay, so hopefully you guys are okay with that so far. So that's equal to, I'm going to put this all on one fraction. So this 2a squared b squared just gets copied down, okay? This ab squared also gets copied down. Now I'm going to distribute this ab to this ab. And that ends up being plus a squared b squared, all right? Then I'm going to distribute this ab to this negative 2b, so that becomes negative 2ab squared. And it's all over our common denominator of a squared b cubed. All right, we're almost there. Now, look at your numerator. Is there anything in common that you can combine together? The answer is yes. I can put this 2a squared b squared with this 1a squared b squared, and I end up getting 3a squared b squared. Okay? Then I can put together this ab squared with this negative 2ab squared, and I end up getting negative 1ab squared. All right, and that's all over our common denominator of a squared b cubed. We are almost done. Next thing I need to do is look at my numerator. Is there any way I can factor it? The answer to that is yes, there is a GCF. Both terms have an a in common, and both terms have a b squared in common. All right, so I'm going to factor that out. So if I divide 3a squared b squared by ab squared, 3 divided by 1, remember there's an invisible 1, becomes 3. And then a squared divided by a becomes a. The b squared divided by b squared cancels each other out, okay? Minus ab squared divided by itself, anything divided by itself is always 1 all over a squared b cubed, okay? And then the last thing that you need to do is cancel stuff out, all right? So this a is going to cancel out with one of these a squareds, and I've got an a here. So I'm sorry, one of these a's I should say. And then this b squared is going to cancel out with this b cubed, and I have a b left over, which means, I'm sorry, I'm going to have to write this on the side over here. My final answer is 3a minus 1 all over ab.